We've all seen videos like this on the internet. Agree, they look pretty good but also incredibly complicated. It probably feels like you need years of practice and an insane amount of money spent on courses to learn how to make something like this. But what if I told you that you could create these insanely cool videos in just a few days or even a few hours? All of this is computer graphics. No modern multimedia program exists without it. But what is it? In short, computer graphics is a branch of computer science that doesn't require hacker-level skills. Computer graphics can be 2D or 3D. D, from the English word dimension, means space. Simply put, every object in the world has directions it can face. The simplest object has only one side, that's a 1D object. Let's say that side is X. Then we get a single line that can be infinitely long. This is 1D. If we add one more axis, another direction, let's say the Y-axis, we get a square. The simplest object in 2D space. In the same way, we can add a third axis to get a 3D object XYZ. So, in our imaginary world, we have an imaginary object with an imaginary appearance. Let's say we want to show it. How? Every computer operates on ones and zeros, which are then written in programming languages. Here's a question. If you want to show, for example, a sun you imagined using only text, in programmer terms, a programming language, how do you do it? That will be our basic 2D object. Let's take a sheet of paper and imagine that we drew something. The first method is to transmit information about every tiny part of the drawing, for example, every millimeter. For instance, the first millimeter, white color, second millimeter, white color, third millimeter, white color, fourth millimeter, yellow color, and so on. This method is properly called raster graphics, where the tiny unit is the pixel. The more pixels, the more detailed the image will be, but the more text we need to write it, meaning the file becomes heavier. For example, a typical resolution for photo or video is Full HD or 4K, 1920 pixels horizontally and 1080 vertically in Full HD, or 4096 by 2304 in 4K. Raster graphics today are the most popular, because they work for almost everything. All camera photos are raster graphics. Its advantages are in its flexibility. Using pixels, you can create any kind of image. It can contain an insane number of objects. Again, it all depends on the resolution, how many pixels the image has as its limit. Remember how I told you that information about each pixel is written as text, or more precisely, in a programming language so that our and other computers can display it? Well, the way this information is stored also differs. One pixel, assuming standard RGB, has 3 color channels, meaning it weighs 3 bytes. Let's take a full HD image as an example. Such an image contains 2,073,600 pixels, meaning it weighs 6,220,800 bytes, which is 6,075 kilobytes, or almost 6 megabytes. It won't always be exactly the same, but it's around that size. For a regular image, 6 megabytes is a lot. So if we want to make the picture lighter, we can store the information like this. Instead of first pixel white, second white, third white, fourth white, fifth yellow, sixth yellow, we can write from pixel 1 to pixel 4 white, from pixel 5 to pixel 6 yellow. This is how compression algorithms work, algorithms that reduce file size. In everyday terms, these algorithms are called formats. For example, PNG, JPG, and others. See, you use them every day without even knowing the difference. But now you do. In short, JPEG, heavy compression, very small file sizes, but with quality loss, great for photos, especially when you have a lot of them and not much storage. JPEG cannot contain an alpha channel, meaning it cannot have a transparent background. PNG preserves quality, supports transparency, not significantly heavier, good for logos, footage with transparency, and more professional images where you need better quality and less compression. WebP, a modern format from Google that combines the benefits of both, but not all programs and devices can display it. It's usually used on websites and online. If you'd like to see a video covering the most popular image formats, their advantages and drawbacks, practical use cases, key differences, and more, feel free to let me know in the comments. By the way, one more interesting thing, sometimes we need part or even the whole video to be transparent. What do we do then? For that, we use the so-called alpha channel, a fourth color channel. It controls transparency, but also makes the file much heavier. For example, PNG is often used in design because it allows for a transparent background. So what else can we use to describe an image? Well, for example, if the image doesn't have too many elements, we can write something like 2 centimeters from the left and 3 from the top point A, 10 centimeters from the left and 20 from the top point B. From point A to point B, a straight yellow line. A very similar method is used in vector graphics, where vectors are used. There is also something called fractal graphics, but it's not as popular or simple, so we won't cover it in this video. Next we have 3D. Well, here everything is a bit harder. First of all, a 3D scene looks entirely different from 2D because it also has a camera, a light source, particles, and so on. So write in the comments whether you want a theoretical or practical video about 3D. And what about color? How exactly do we store it? How does the computer know what color each pixel should have? Take a look. This is the painting Ukrainian Hut by the Ukrainian artist Ilya Repin. If we wanted to draw a perfect copy of this painting, we would need to transmit all colors 100% accurately. To do this, we take 3 primary colors red, yellow, and blue and mix them in the correct proportions. And now the question for you: how are we supposed to determine the exact percentage of any given color on a piece of paper? Well, we're not robots, so unfortunately we can't guarantee perfect precision. But if we could, we'd say something like 22.5% yellow, 55.25% red, and 22.25% blue. That's exactly how it works on a computer, except instead of yellow, the third color is green. Why green? Because, to put it very simply, light is a wave. And every color has its own wavelength. If you look at a graph, you'll see that red light has long waves, blue has short waves, and green lies almost in the middle. If that's too complicated, imagine a rainbow. It's a perfect example of how light works in our world. Which 3 colors are almost evenly spaced there? Red, blue, and green. These 3 form the color space called RGB: red, green, blue. So if we want to store information about a pixel, we write how much of each of these 3 colors it contains. If you need help with any video, animation, graphics, and more, you can contact me through Fiverr and we can agree on a collaboration. And where exactly is computer graphics used? Well, almost everywhere. All video games without exception, some are 3D, some 2D. Movies and TV shows also use special graphics created on computers called CGI. Everything you see on the internet, every logo you look at daily, every video, image, drawing on your computer. Even if you're not a designer or programmer, you use computer graphics every day. For example, Instagram filters are computer graphics. The meme you saw, graphics. A banner on a website, graphics. A button in your favorite game, graphics. Even when you open Simple Paint or PowerPoint, you're already creating your own graphics. All of us dive into it every single day, so don't be afraid. If you can draw a little line in Paint or create a slide with text in PowerPoint, then motion graphics, 3D animation, CGI, and even Hollywood-style visual effects are something you can learn too. Together we can explore and dive into the world of computer graphics, video editing, animation, and design. And this isn't some overpriced course of mine, it's my free YouTube channel, where your feedback helps us improve the content and prove that multimedia is simple, and that you don't have to spend a fortune to learn it. Subscribe and become a part of AGP Studios, because your subscription isn't just a number, not just a single digit among a million, it's a sign of appreciation and real support for our channel, which we're building together with you. By the way, when you see a finished image, animation, or 3D scene, that is the result of what's called rendering. Rendering is the process during which the computer transforms a digital model or description of an image, made of numbers, formulas, textures, light, etc., into an image we can see on the screen. It's like the final stage of visualizing everything you've created. In 2D graphics, rendering is usually very fast, it just puts pixels in the correct order. In 3D graphics, everything is more complex. The computer must calculate light sources, shadows, materials, reflections, viewing angles, and much more. That's why 3D rendering can take hours and sometimes even days, especially for movies. Film is not that simple either, because you also need to know how to edit it. And for that, this video will help you. And you'll definitely enjoy this video too. Learn, because you've only got one life. I'm Andrew from the AGP channel. Good luck!